This is for chapter 3.1, this video. We'll cover numerically summarizing data, and we'll be talking about measures of central tendency. Make sure you have your note sheets out. And so what we're looking at is, based off our conversation, that data tells a story, and one way that it tells a story is through the numerical values that we can use to describe the data. And the most common one that you already have is called arithmetic mean. That is just the word average. We've used the word average in the past for that word, arithmetic mean. You just add up all the values and divide by how many you have. Now, you have to pay attention that if we calculate the mean from a population, right, called the population, it's a parameter and it's called the population mean or population average, population arithmetic mean. And we use a symbol to distinguish the mean of a population mean. We have all of the data from all of the individuals. We use this symbol and we say it mu. That's how it's pronounced. And we use that symbol, so get used to it. Sometimes, and most of the time, we take data from samples. And so when we do the mean from the sample, we call that a sample mean, or we call it X bar for short. And that's the term we use. So just again, get used to it. That's a statistic because it's coming from a sample. So get used to that. Here are the formulas we use. And again, we don't use the formula. We're going to do this you've done these calculations by hand in the past, but now we're going to use technology. And notice we're dividing by big N, which is the number of observations in the population, versus again little n, which is the number of observations in the sample. And so on your note sheets, of course, you're going to have this information there. So go ahead and get that. Get that down. Okay, you can pause the video if you need time to copy that down. Those are the formulas again, but we will use Statcrunch to do that. So again, first example, instead of calculating all of these, let's say this is a population. These are all the students from a stats class, and this was their average score on the first exam. Compute the population mean. And so what you do is you add up all those values. You would take 82 plus 77 plus ... all the way to 88, and then divide this, since this is a population mean, then divided by 10, and then you would get your answer. Now, what we're going to be doing in this class is using Statcrunch to do this. And so I have the data in already in Statcrunch. There it is right here. There's the first example, and then what you do is summary stats, column, and then from there, I want this example, and then you can click just mean right there, and then with that there, you get your answer. Hit compute, and you get an answer of 79. So again, that's the answer that we would put into this here. When we add them up, you would get 79 right there. And so that would be the population mean, mu, right? The mu, the way we say that, mu or mu, okay, how you would say that. Now, if we did a sample of 4 students, we would be calculating the sample mean. So find a simple random sample of 4 students. So let's go ahead and to find a simple random sample, I need to pick 4 people from that population. So I'm going to use the applets. I need to pick, where's the random numbers, and I want to pick 4 random numbers from 1 to 10. And then we would go ahead and do 4 there, and then you compute, and so we get 10, 4, 9, 6, 10, 4, 9, 6. And so what we would be doing is finding, we ended up choosing 10, 4, 9, and 6. So your little n is 4. In this case here, the population mean, our big N was 10, because we used the entire population. And so if we were going to calculate the sample mean, you would just do 10 plus 4 plus 9 plus 6 divided by 4, 14, 20, 29 divided by 4, and that looks like 7.75. And so that would be a sample mean, or X bar. And so that's what we're looking at for calculating the arithmetic mean, population and sample. And that is what we call a measure of central tendencies, because it's telling a story where the middle of the data is. So that's part one of the video.